Here we have an infinite series with the expression 1 over 25 n squared plus 5n minus 6, and I want to show that this infinite series converges to 1 over 15. So the first thing we want to do is decompose the expression 1 over 25n squared plus 5n minus 6. And the equivalent expression would be 1 over 25x squared plus 5x minus 6. Down here, the factors are 5x plus 3 and 5x minus 2. And then using what's called partial fraction decomposition, we can rewrite this as a constant a over 5x plus 3 plus constant b dividing by 5x minus 2. To combine these two expressions, we can cross multiply. So it would be constant a times x, 5x minus 2, plus constant b times 5x plus 3, and dividing by the product of 5x plus 3 and 5x minus 2. From here, we can see that 1 is equal to a times 5x minus 2 plus b times 5x plus 3. This equation is true for all x, so we want to pick something that would make this factor 0 and this factor 0. So let x be 2/5, because 5 times 2/5 is 2, 2 minus 2 is 0. So in the place of x, we have 2/5 and 2/5, and this part will be 0. And then here we get 5b equal to 1, so b is 1/5. And then to make this factor 0, we can let x be negative 3/5. So in the place of x, we have negative 3/5. This part will be 0. And then here we get negative 3 minus 2, which is negative 5. And so 8 is negative 1/5. And so the expression 1 over 25x squared plus 5x minus 6, we can rewrite it as negative 1/5, since 8 is negative 1/5, over 5x plus 3, and then plus 1/5, since b is 1/5, over 5x minus 2. And so this is the same thing as 1/5 over 5x minus 2 minus 1/5 over 5x plus 3. And hence the original series, infinite series, we can rewrite this as 1/5 over 5n minus 2 minus 1/5 over 5n plus 3. To get rid of the fractions here, multiply the top and the bottom by 5. So multiply by 5, we get 1. Multiply by 5, we get 25n minus 10. And then same thing here, multiply by 5, we get 1. Multiply by 5, we get 25n plus 15. And now let's form some partial sums. The sum of the first 5 terms is 0.0 0.05595. Sum of the first 10 terms is 0.062893. Sum of the first 100 terms is 0.066269. Sum of the first 1,000 terms is 0.0666269. Sum of the first 5,000 terms is 0.06665866. Sum of the first 10,000 terms is 0.06666266. And then sum of the first 100,000 terms is 0.066666266. So now let's write the sum of the first k terms is our infinite series with the expression 1 over 25n minus 10 minus 1 over 25n plus 15. So let's generate the first 10 terms. So these are the first 10 terms. This is the kth term. So in the place of n, we have k. And then to form this term in the place of n, we would replace n with k minus 1 and then simplify. For this term, replace n with k minus 2, simplify, and we get this. Here, replace n with k minus 3, and then k minus 4, k minus 5, and so on. But this series, we can see that this term and this term will get cancelled, and so we can see that all of these will get cancelled, and they will drop out. And then we can also see it right here. And then eventually this term will also drop out. And so what's left is just the 1 over 15 minus 1 over 25k plus 15. So the sum of the first k terms is 1 over 15 minus 1 over 25k plus 15. This is the original series, infinite series, which is the same as the limit of s sub k as k approaches infinity. So once again, sum of the first k terms, and if we allow k to run to infinity, then we get the infinite series. But s sub k is 1 over 15 minus 1 over 25k plus 15. As k approaches infinity, this term approaches 0, and so we get 1 over 15 minus 0, which is 1 over 15. So we say that the original series with the expression 1 over 25n squared plus 5n minus 6 converges to 1 over 15. And that's the end of the video.